one of the greatest mysteries in the universe. And the strangest part is that it's everywhere, around us, through us, surrounding every galaxy, shaping the cosmos itself, yet we can't see it, touch it, or interact with it in any ordinary way. Everything we know, everything we can detect with our eyes or our instruments, makes up only a tiny fraction of reality. Stars, planets, galaxies, gas, dust, black holes, you, me, everything familiar accounts for less than 5% of the universe. The rest is made of something invisible, something silent, something that passes through Earth, through buildings, through our own bodies without us even noticing. Scientists call it dark matter. The name might make you imagine shadows or voids, but dark matter isn't dark the way a room gets dark when you turn off the lights. It doesn't block light, it doesn't reflect it, and it doesn't emit it. It simply doesn't interact with light at all. It is more like a gravitational phantom, unseen, untouchable, yet absolutely essential for the universe to exist in its current form. The idea started with an eccentric Swiss astronomer named Fritz Zwicky in the 1930s. While studying a cluster of galaxies, he noticed something bizarre. The galaxies were moving far too fast. According to the laws of gravity, the cluster should have ripped itself apart, its galaxies flinging away into the darkness like sparks from a spinning wheel. But they stayed together, as if an enormous, invisible weight was holding them in place. Zwicky did the math and concluded that most of the mass wasn't visible. There had to be something else, something hidden. He called this mysterious substance dark matter. Almost no one took him seriously at the time, but his idea lingered in the background of astronomy for decades. It wasn't until the 1970s that dark matter re-emerged, thanks to the work of astronomer Vera Rubin. She studied how stars move around galaxies. According to Newton's laws, stars near the center should move quickly, and stars farther out should move more slowly, just like planets in our solar system. Mercury races around the sun, while Neptune drifts along at a crawl. But Rubin found something that defied logic. Stars far from the center of galaxies weren't slowing down at all. They were moving just as fast as inner stars. In fact, many were moving so fast that they should have flown off into space. But galaxies weren't flying apart. Something was holding them together. The only explanation that made sense was that galaxies were surrounded by massive, invisible halos of matter. Rubin's work convinced the scientific community that dark matter wasn't just a curious idea, it was a fundamental part of the universe. But even today, with decades of research and mountains of evidence, we still don't know what dark matter actually is. We can't see it with telescopes because it doesn't interact with light. We can't touch it because it barely interacts with normal matter. We only know it exists because of its gravity. Dark matter provides the gravitational glue that holds galaxies together. Without it, galaxies would unravel, stars would drift apart, and the universe would look nothing like it does today. Dark matter is the scaffolding of the cosmos. If the universe were a giant building, the bright visible stuff would be the decorations, the paint, the furniture, the lights. Dark matter would be the steel frame, invisible but vital. Simulations of the universe have shown just how important dark matter is. When scientists recreate the cosmos inside supercomputers, they input the laws of physics, the amount of matter, the forces of gravity, and the conditions of the early universe. If they leave dark matter out, nothing works. Galaxies don't form. Stars don't cluster. The structures we see through telescopes simply don't appear. But when dark matter is added, everything changes. Large-scale structures emerge, enormous cosmic filaments stretching across billions of light years, galaxy clusters, walls, and vast empty voids. This giant, web-like pattern is called the cosmic web, and dark matter forms its threads. Galaxies gather along these invisible filaments like beads on a string. Our own Milky Way is just one bead among trillions. But what is dark matter made of? No one knows, but scientists have proposed several possibilities. One idea is that dark matter consists of WIMPs, weakly interacting massive particles. These hypothetical particles would pass through ordinary matter like ghosts. Billions of them might be streaming through your body every second, never leaving a trace. For years, WIMPs were the leading theory, and huge underground laboratories were built to catch even a single one. Imagine giant tanks of ultra-pure liquid buried deep underground, waiting for the faintest flash of light that might occur if a dark matter particle collided with an atomic nucleus. But so far, these detectors have remained silent. Another idea involves axions, ultralight particles that could be swirling through the universe in massive quantities. If axions exist, they might interact with strong magnetic fields in unusual ways. So scientists have built elaborate experiments to search for these signals. Then there are sterile neutrinos, hypothetical cousins of regular neutrinos, which already pass through matter almost effortlessly. Sterile neutrinos might behave in just the right way to account for dark matter, but evidence remains elusive. Some physicists think dark matter might be something even stranger, something entirely outside the standard model of particle physics. It could be an entire hidden sector of particles, a kind of shadow world that interacts with our universe only through gravity. In a playful twist, some scientists even speculate that dark matter might have its own forces, its own interactions, maybe even its own dark light that we simply cannot detect. It sounds like science fiction, but the universe has repeatedly proven that reality can be far stranger than anything we imagine. Searching for dark matter has become one of the most ambitious scientific quests of our time. Because it doesn't interact with light and barely interacts with matter, detecting it is incredibly difficult. Scientists have had to get creative. Underground detectors attempt to spot the rare collisions between dark matter particles and normal atoms. Particle accelerators like the Large Hadron Collider smash particles together at immense speeds, hoping to produce dark matter. They look for missing energy evidence that invisible particles escaped detection. Space telescopes search for gamma rays or other telltale signs that might be produced if dark matter particles annihilate each other. So far, the results are tantalizing but inconclusive. The universe seems to be hiding its secrets well. Still, we know dark matter is out there because its gravitational fingerprints are everywhere we look. It shapes the rotation of galaxies. It binds galaxy clusters together. It bends light around massive objects in a process called gravitational lensing, which allows us to map dark matter's distribution even though we cannot see it directly. It influenced the formation of the first stars and galaxies. It governs the structure of the entire cosmos. And yet, for all we know, we are still in the early stages of understanding this invisible substance. It might take decades or centuries or a completely new breakthrough in physics to finally reveal its true nature. Dark matter could be something simple or something unbelievably complex. It might be discovered in a quiet lab deep underground, or in the data from a space telescope, or in a burst of insight from a physicist still in grade school today. What we can say for certain is that dark matter is a reminder of how much of the universe remains unknown. We live in a cosmos filled with mysteries, and dark matter is one of the biggest. It surrounds every galaxy, holds the universe together, and flows through all of space invisibly. It is a silent force shaping everything we see, a hidden ocean filling the vastness of the cosmos. The universe we know, its galaxies, its stars, its structure, would collapse without it. Most of reality is still concealed, waiting for us to uncover it. The search continues, and with every discovery, we get one step closer to understanding the invisible fabric of the universe.